Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is the next problem, the next installation about the same body that sits on the surface, and it sits on the surface and the external force F is applied, and this F is 2 or 4 newtons. And they want to find us acceleration in this direction. The only thing that's all located in the elevator. And the elevator rushes up with some acceleration A1, say for example A1 equal 5. And so they want to solve us in this situation. So nothing much changes. We still have either static or kinetic friction. We don't know what it will be before we try to solve the problem. We only know that to distinguish between friction, kinetic and acceleration, there are two things. First, acceleration in this way, in this direction of the surface. And second, we know that maximum friction is mu n. We don't know if in this situation it would be more than maximum or less. If it would be less, it would be acceleration equals 0. If friction reaches its maximum value, then yes, it would be acceleration. And so it would be either kinetic or static, but we don't know. So everything now depends on n. So, as always, sum of all forces equal ma. A is total acceleration. In this particular case, we have, as always, mg vector plus n vector plus f friction vector plus f equal ma. And a is vector. And let's say that this is a1 and this is a2. And so A1 is given and A2 they want to find out. So A1 is vertical, A2 is horizontal. So axis, because we don't deal with vectors very well, we're very good with one-dimensional projection. Projection mg 0, projection n 0 on x because it's perpendicular. F friction minus F friction, right? Plus F equal ma2, because this is acceleration in this direction. Y, mg minus, n is up, so it's plus. Those two are zeros, because they have no projection on y. And m, projection A is A1, vertical projection, and it goes up, ma1. Fantastic. And immediately we can find n from this second one. N equals ma1 plus mg. And we have to find out F frictions, the maximum F frictions that it's ever can be F friction max. And this kind of threshold, if the force that we will be applying is more than that, it would be kinetic friction and everything will go. If the force that we are applying is less, then it would be static, no movement in this direction. So is it more than max or less? So what do we have to find this? And this would be mu n, and this would be mu m. I can factor m out, and I can put a1 plus g. And I can plug the numbers here, and this would be 0, 3, m is 1, a1 is 5, 5 plus 10 is 15, 0, 3 multiplied by 15, it would be 15, 4.5. It would be 4.5 Newton. So this is a critical force that will distinguish between static case or kinetic. And now let's look on the horizontal. We have F and F is only 2 or 4, but less than 4.5. That means that in this particular case, A2 equals 0. And F friction would be equal F, because this would be 0, and it would be static case, and F friction would be either 2 if we apply 2, or it would be 4 if we apply 4, but in all cases it would be less than 4.5. That means that if we're moving in the lift, in the elevator that goes up and grows up, instead of normal gravity, it has to be more, because the floor of the elevator pushing this body up, and the body goes with some acceleration up, and n is bigger. Instead of 10 it is 15, and because it's pressed more into the body, the friction, the maximum friction before it starts to slide to the side, is more than before. Before it was only 3 newtons, and now it is 4.5 newtons. And we, in both cases, applying the force at less than that. So nothing changes, the body stays. This is static case, it's not moving here. A2 equals 0, and the friction equal F. And let's take a look next time on what happens if we're going down. For that you have to subscribe and bell, and then you will be notified when I put the second program. Thank you.